Okay, so we have those two examples in the book that we've just been talking about, and now I want us to look at the couple of examples that I have here on the notes for you also. So I want you to take your pencil down, I want you to underline that a leaf is only going to be the last digit. Now, I just said the leaves are the ones place. Typically, they are the ones place, but sometimes we can have decimals involved in data sets, and then they might end up representing a different place value. We will work with whole number data sets only. So in our case, the leaves will be representing the ones place, okay? And then the stem will be the rest of the digits, the digit or the digits other than the last digit. So they're the rest of the digits might be a way to say it. So the leaf represents the last digit. The stem is going to represent the rest of the digits, basically. So if your data set has something in the thousands, your stem is going to have 3 digits to it. And your leaf is still going to represent just the ones place. Okay? So in this particular one, it doesn't tell, oh yeah, it does. It tells us that the amount of money collected by each student for the drama club is shown below by each student. So they must have been collecting some money. Use the data to make a stem and leaf plot. What I was trying to get you to tell me a stem and leaf plot does is it starts with the smallest value, it ends with the largest value. Everything is in order. Notice something else. We can have repeat leaves. If there are 2 data values that are the same, they each get a spot in the stem and leaf plot. That one does not get left out. If there's 6 of them that have the same data value, all 6 of them are going to get represented. We never leave out a stem. Once we decide what the smallest stem is and what the largest stem is, we just number every one of those, whether we're going to use, whether they have leaves or not. So in this particular case, the 7, the stem of 7, which represents 70, and this is probably dollars since it says money, $70. We didn't have a student who collected any amount of money in the 70s range, but notice the stem 7 is still there. Okay? How many data values? I don't want you looking over here. I don't want you doing anything with that. I want you to tell me, looking at the stem and leaf plot, how many data values, how many students are represented in that stem and leaf plot? How many? What do you have to do to figure it out?
There's one unrepresented.
There's what?
There's 0 represented.
No.
7.
How many students, amount of money collected is represented in there? All we have to do is count up the leaves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, like Devante said. So my point being here, when you are done making your stem and leaf plot, you need to go back to your data set. And you better make sure that you have the same amount of values there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We don't want to leave any of our data values out. We want to make sure we have them all. Okay? So that's just a single stem and leaf plot. That one's representing. The next one is representing test scores from 2 different math classes. So here I am, I'm comparing test scores between Class A and Class B. So maybe I have my Algebra A and I have my Algebra B students, and I'm comparing test scores. And I made a back-to-back stem and leaf plot. How many students do I have in Class A? How many students took this test? 1, 2, 4 more, that's 6. 3 more, that's 9, 10. How many in the other class? Class B, 7. So we got 1, 2, 3. 2 more is 5. 2 more is 7. 3 more is 10. Yeah. equal classes, they each have 10 students in them. Okay, now, when I go here and look at this again, I should make sure that I have 10 values in each class there to make sure that they're all represented. Any people ace this test? How about in class 8? Anybody ace the test? No? Let me get all this out of here for now. So in class A, that student got 100. One student got ace the test in class A. Anybody ace it in class B? How many? 3 of them. 3 of them got 100. What was the lowest score between the two classes? What was the lowest score between the two classes? Just a 50. Class A, the person who got a 50 in class A had the lowest score out of between the two classes, between all of them. Okay, so we also need to know how to read these stem and leaf plots. Okay, let's do one together here. Looks like we're going to make a back-to-back one because we are going to compare the daily low temperatures in degrees Fahrenheit in a town in the Northeast and to the daily high, apparently. So daily low temperatures, it should also say daily high. I don't know why it doesn't, but it doesn't. So use the data to make a back-to-back stem and leaf plot because we have 2 different data sets here. So when we are doing this, the first thing we're always going to do is with each data set, we're going to determine what's the lowest number in each data set. Okay, so what's the lowest number in the daily low temperatures? 36. 36? I don't see a 36.
It's right there.
Oh, right there. Okay, let's underline it. Okay. Probably the lowest temperature altogether, since the next chart represents the daily highs, but let's just double check. What was the lowest daily high temperature? 65? Right here. Cody, I want your head up, please. 65? Anybody see one any lower than that? I do.
62.
I see a 58 over here. I'm going to erase my line under the 65. I don't agree with that one. 58. Now, don't quit looking until you're absolutely certain. Anything lower than 58?
No. Yes, there is.
What is it?
Well, daily high.
In that table. In that table. Okay, so now between the two, which was the lowest?
36.
The 36. So that means our first stem is going to be a 3. 36. We need 3 tens. Now, we're going to look for the highest temperature in each of them, just because we need the highest between the 2 of them together. So what's the highest in the daily lows?
That'd be 63.
Looks like it's right here. Let's put a square on that one. What's the highest in the daily highs? 84. Okay, I think I agree. Which of those two is higher? 80. Okay, 84. So we have to go all the way through the 80s. Do we leave out any stems? No. So 4 for 40, 5 for 50, 6 for 60, 7 for 70, 8 for 80. And we don't have to go any higher. Okay, we're ready to make our leaves. Let's do the daily lows first, okay? So I underlined 36, so let's underline all the 30s. All the temperatures that were in the 30s. Are there any others?
There's
There's a 39. Any others? Okay. So that means when we're doing the lows, we work, remember, from the inside out. We go from smallest to greatest. So the first leaf is going to be what? 6. Leave a space. Don't put them back to back. Leave a little space. And what will our next leaf be? 39. Okay. Now we'll go to the high temperatures. Are there any in the 30s?
No.
No, our lowest was 58, right? So there won't be any leaves in the high temperature for the stem 3. Okay, now let's go to the 40s. Go back to our low temps. How many do we have in the 40s? Let's circle those, okay? So 40, a 49, a 48, a 49, a 40, a 42, a 44. Looks like there are 6 of them. You're right, Cody. Okay, all 6 then, we need 6 leaves, that means. What's our first leaf? 0.
No, there's 40, there's 7.
Where's there another one?
There's 2 9s.
240. I know, but there's still only 6.
1, 2, 3, 4, 5, 6, 7.
Where's the 7th?
4, 5, 6, 7.
He's right, there are 7. Thank you, Cody. There's 1, and then there's 4, that's 5, 6, 7. Okay, so we need 7 leaves. Okay, so we're going to start with leaf 0. What's our next leaf? 0 again. So line that up nicely under the 9. You should have nice straight columns going on in this. What's our next leaf?
2.
A 2. What's our next leaf?
4.
No more 2s?
No.
Need another 4?
Nope, there's 8. And then 2 9s.
I'm writing so big, I'm going to go into my table here. You guys can you can erase if you need to, scale yours down. I should too, because I really can't see what is left in there now. Okay. So I had a 36 and a 39. Can't write so big, I guess. Five, 6, 7 leaves. Okay, all is well. Okay. Any temperatures in the 50s in that
Yes,
table?
there's 6 of them.
6 of them. Okay, how about with the shape we use this time as a triangle? 1, 2, 3, 4, 5, 6. Okay, go ahead and get your leaves made for the 50s. All the temperatures in the 50s. There should be 6 leaves. From least to greatest, working inside out. So notice you don't have to have a column for 0s, a column for 1s, a column for 2s, etc. They are lined up in columns according to how many there are. Okay. Any temperatures in the 60s?
Yes.
Our last 3, right? So our last 3 we can put our square around, and we have a leaf of 0, a leaf of 2, a leaf of 3. Okay, before you move on to the next one, here's what you do. You count up your leaves, you count up how many should be in the table. That's a 3 by 6 table. How many are there? How many data values are there? 3 by 6? 18. So we should have 18 in our table then. 4 plus 4? 8 plus 3? 8 plus 3? 11. 2 more? 2 more? 2 more? 17, and there's my 18. Do the same thing in your table. Make sure that you have all of them represented, because that throws your whole data display off if you're missing anything. Okay? Okay, you go ahead and do the other side now. Okay, go, Cody, do yours up there while they're finishing up. When you change your eraser, you need to make it smaller. There you go. I have it really big. Kind of want to make sure you have this one. You should have 18 also. Just make sure. I'm only seeing 17. Now did you count it up? Make sure there's 18.
Yes. 17 before, now there's 18.
You're missing a 5.
Oh, that's 65.
And you guys check them out. Make sure you agree with them. Okay, we're not done yet. Anybody know why? Tomorrow, if this is all you have, I'm going to say your homework's not done. I think they give me the reason why I'm going to be so picky. Yeah, we need a key. You are not done until there is a key. No, but thanks for offering. When you write a key and you're doing a back-to-back stem and leaf plot, you have to tell the reader how to read numbers on both sides. So you get to pick. Your key may not be exactly the same as somebody else's key. You get to pick, but you have to pick one. You have to pick something from both sides. So I'm going to do the low temp one. I am going to use, just out of the randomness of I'm going to use that one. So notice where that came from. There's my stem 4, there's my leaf 2. Doesn't matter where it's from. Does not matter where it's from. What does this mean?
Means 40.
42. And then we have to do one for the other side. And again, I get to pick whichever one I want to do, and I'm going to do that one. I'm going to show that my stem is 7, my leaf is 3. This means 73. We have to show how to read it from both directions. Okay, and we don't have to underline them in the semi leaf plot like I did. I was just doing it to make a point right now. Yes, Michaela?
Is it always low, high, or does it matter?
What do you mean low, high?
Like, could we do high, low first, or is that wrong?
You know what? It wouldn't necessarily be wrong, but because we read something from left to right on a page, chances are, somebody's going to look at it. Would be easier for them to look at this first, do this side, the left side of the stem and leaf plot first, be wrong, as long as, here's what's important, really important, is when you're doing it from the left side, the leaf has to be on the left of the stem, doesn't it? When you're doing it from the right side, the leaf has to be to the right of the stem. That's the really important part, okay? Any other questions? Okay, let's get going on your homework.